and I'll just say it again for the recording. Hi, I'm Kody. I'm a backend engineer. I've been working on Bitcoin for a while, and today we're going to talk about synthetic US dollars, right? And so there's a couple different options for US dollars, and synthetic US dollars is something that you can do via OKX. There's already a working implementation for it, and it's going to be very exciting to go through this. So let me start sharing my screen. Desktop one, share. What's this? I get a thumbs up if you guys can see the slideshow. Yes, I think you can. I see something in the chat. Okay. I'm going to assume you guys can see it. Okay, cool. All right. So the current context, right? So just in the last couple of weeks, we've seen a lot of crazy movements happening in like global markets generally, but especially in Bitcoin and crypto, right? So you see on the right, this is something that a guy who's pretty popular on crypto Twitter, Balaji, has been saying. He put $1 million bet down that that Bitcoin was going to hit $1 million in the next 90 days. And the reason why he thinks so is because there's going to be a bunch of bank failures and those kinds of things in the coming weeks and months. That's like, pretty scary stuff, right? But it's also something that, I think we have a solution for it with synthetic US dollars. And that's something that I really hope that you guys will try to hack on during this hackathon, right? So like the current context is that banks are over levered and failing. Hopefully none of you got caught up in the Silicon Valley Bank situation last week, or Signature or Silvergate, right? But those banks that aren't failing right now, the ones that aren't like actually going under, they're under enormous pressure to not service crypto companies. So every crypto company is facing this problem right now of like, how do we handle US dollar liabilities, right? People need US dollar liabilities because US dollars serve as the global unit of account. And so even if it's like you entirely get cut off from the banking system, you still need to use US dollars because all of the debts, expenses, salaries, all those sorts of things for running a business, they're denominated in US dollars on one side of the balance sheet. And so you need a way to denominate in US dollars on the other side of the balance sheet, on the asset side. So OKX is currently looking for solutions to the above problems. And so I'll kind of walk through the current solutions that are looking at it, and specifically at synthetic US dollars, which is something that does not require any banking relationships, is something you can do today using OKX derivatives. So here we go. There we go. Cool. So current USD options, right? There's basically dollars over US banking rails. There's stablecoins, and stablecoins require a banking relationship with the issuer, where like the stablecoin issuer, so it could be Circle, it could be Tether, it could be whoever, they have a banking relationship, and you deposit $1 with them. They keep it at the bank for you, and they give you a token that represents that value. And so while for using the stablecoin on your end, you don't require the banking relationship, you just need the relationship with the issuer. The issuer still needs to have a banking relationship. And then there's derivatives, which is synthetic USD, specifically stable sats, which is the implementation we'll be talking a lot about today, right? So let's go through each one of these. So like, do we want to use dollars within crypto, like over normal US banking rails? Well, a lot of people want to use dollars over US banking rails. But the problems in the last couple of weeks is that using banks may no longer be an option, right? Like there's a bunch of regulators going after all of the banking relationships for all of the existing crypto companies. This is from Nick Carter, who's a crypto writer who's pretty popular. He kind of summarized a lot of the actions in the last couple of weeks. This was before a lot of the failures, right? This was just the actions they took in the lead up to it. And after the failures, they've been even more, right? But just to kind of quote him, in some, banks taking deposits from crypto clients, issuing stablecoins, engaging in crypto custody, or seeking to hold crypto as principal have faced nothing short of an onslaught from regulators in recent weeks. Time and again, using the expression safety and soundness, they made it clear that for a bank, touching public blockchains in any way is considered unacceptably risky. And so while plugging into existing legacy US dollar banking rails is something that like very, very convenient for certain things, like a lot of people already use them via credit card rails, those kinds of things, it may no longer be an option, right? So let's look at another option that we could have for US dollars. Stablecoins. Stablecoins also rely on banks, right? So while the user doesn't actually need a bank account, they just need an account with the issuer or something that the issuer has issued a token on, right? Whoever is issuing the stablecoin requires a banking relationship. And we saw this happen in the last couple of weeks, where Circle, which is like one of the big, I think it's the second largest stablecoin issuer. There's like Tether and then Circle. They're like all US regulated. That was like their big selling point. We're regulated by the US. We keep all of our stuff in US banking deposits, and therefore they're safe. They had $3.3 billion of their $40 billion of USDC reserves stuck in Silicon Valley Bank. And so during the time that it looked like Silicon Valley Bank was going to fail, that stable coin depegged from the what's called the dollar that it was depegged from the dollar and went down. It ended up going all the way down close to like 80 cents on the dollar, right? And so, like, you know, lucky for them, Silicon Valley Bank got bailed out. But like, what happens if this happens more and more often and more of their banks start failing, right? So like stable coins also introduce this banking risk. And as the banks continue to lever up, as they continue to get more and more levered, relying on the banks in any way is something that has like a huge number of risks associated with it, right? So just kind of like summary for this is that Bitcoin is our opportunity to create a permissionless financial system. Like using Bitcoin, using crypto, using these rails that we're creating, you don't have to ask anyone's permission. You don't have to put your deposits with someone who rehypothecates and lends them out on the back end if you don't want to, right? Having to ask permission of USD banking entities is a problem. So what's left? There's derivatives, right? And so we'll kind of walk through how this synthetic USD like math works. But the important part is that there's no banking relationship required for the user or on the part of the place where the user is doing the trading, right? They just have to use the exchange. And so just using Bitcoin and using OKX together, you can create a stable USD position. And we call that synthetic USD because it's not actually a token. It's not actually USD. It's a short position on an exchange and a long position on Bitcoin that you hold. And the net movement of those two assets creates a stable USD price. Okay. So like a lot of technical terminology there. We're going to go very deep into the details of this and into an actual working Rust implementation who uses OKX in order to do this hedging mechanism. Okay. Cool. So a little background on synthetic USD. So synthetic USD was first proposed by Arthur Hayes, who is the founder of BitMEX. He's like a very big guy within the crypto world. He outlined how to create, store, and spend synthetic USD using derivatives. So in 2021, the Standard Sats project introduced the idea of Euro Bitcoins during a hackathon. So instead of synthetic USD, doing synthetic EUR, just because using this hedging strategy, you can like basically denominate it to anything that you want, right? You just need to say, hey, here's one position, here's the short of that position that moves inversely. And as they move in a different direction, they move at the same rate. And so the net between them stays stable, right? We'll go very deep into those details. In early 2022, Collider published a Twitter thread recapping the ideas and projects on their synthetic stablecoins on Lightning. And last week, Arthur Hayes published another article called Dust on Crust on synthetic USD, which he called for the Naka USD, which is like the Nakamoto US dollar, which would require a DAO among a bunch of exchanges, an ERC20 token for governance of the DAO, Bitcoin, and an exchange on which to do these hedges, right? Now, this is like very complicated and there's like all sorts of trade-offs associated with it, particularly like, you know, who decides who's in the DAO? How do you distribute the tokens? Why do you even need an ERC20 token in order to do these things? All sorts of questions like that. There's a currently working implementation of synthetic USD called StableSats, and it uses BTC on OKX in order to do it. It requires no DAO. It requires no token. It's just Bitcoin and an exchange on which to short it. So Galloy Money is like a project building open source Bitcoin banking tools. They were actually very critically involved with El Salvador making Bitcoin the legal tender for legal tender because they like created the Bitcoin Beach wallet. And they've been building a bunch of banking services around it, and they don't have access to USD banking rails. And so they built this to solve their own problem of giving USD bank accounts to people, well, things that operate like USD accounts to people who can't pass the KYC processes just because, like, you know, they're in El Salvador, they're like, don't have access to a lot of technology. And so like, they can't go through like the normal KYC process and all those sorts of things that you would have to do in order to get a US bank account, right? The StableSats project, which is what they call their synthetic USD implementation, is entirely open source, but it's currently coupled to Galloy's backend. And so the technical walkthrough that we're going to be going through later are just the steps that you're going to have to do if you want to hack on this project and like use synthetic US dollars in the project that you're working on. The steps that you're going to have to go through in order to uncouple it from Galloy's backend and point it at like whatever you want to point it at. So like another Bitcoin node, a core Lightning implementation, a Fedimint module, pointing it at OKXchain, pointing it to like an EVM smart contract, whatever it is. Like we're going to go through how do you uncouple this from the Galloy backend and point it at whatever you want. So yeah, okay. So again, it's just BTC and a place on which to trade it, right? And this, instead of BTC, if you wanted to, you could use like ETH, but you need something with like very deep liquidity and trading pairs that you can short against, right? So Okay, so the point of synthetic US dollars and how it works. Arthur's like summarizes the purpose of creating synthetic USD is to have as much personal control over your wealth as possible. Is that you still have, it's not self-custodying Bitcoin. It's not that same level of security. However, of the ways to get USD and get it to operate in the way that we want it to, of having a stable price so that, for example, I can use it as like the USD side of my balance sheet so that I can pay my USD expenses, that sort of thing. That's what this is really good for, okay? You need an exchange on which to trade this. And so you're trusting the exchange to some extent. But we're going to go over some implementation possibilities of how to use multiple exchanges, how to get price oracles from multiple sources, those sorts of things. But the point of this is to have maximal control over your wealth as possible, is that I'm choosing to hold US dollars in this way because I don't want to put it in banks that are going to rehypothecate it on the back end, right? So here we go. Okay, so this is like one of the problems is that we want, like, for us, like crypto traders and like Bitcoin traders and stuff, like we don't want this. We don't want Bitcoin to just sit here and not do anything, right? But generally speaking, Bitcoin does not just sit here and not do anything. The price does not remain stable. Like sometimes it does this, right? So, you know, it's like, let's say like I'm using Bitcoin for business or I'm using crypto for business, right? I accept the tokens and the price dumps down on me. Well, now I can't run a successful business if I'm doing it this way. I need to lock in the US dollar value at the time that I do the exchange, right? But while it goes down, it also goes up as it's been doing the last couple of weeks, right? But so if I'm operating a business though, I don't want to be exposed to this price risk. I want US dollar price stability. And so because users want US dollar price stability, they go to banks and they use those for the US dollars. They love US dollar price stability, but they don't want to touch the banks. And this is a way that you can do this without touching banks, getting US dollar price stability, right? Okay. So this is really important before we go on, right? Because the way that we're going to be doing this US dollar price stability is that we're going to have Bitcoin on one side, or you could use ETH or whatever it is. We're going to use Bitcoin for these examples. Bitcoin on one side and shorting Bitcoin via derivative contract on the other side. And the movement of those two nets out to a stable US dollar value. Okay, so a derivative is a contract between two or more parties whose values based on agreed upon underlying financial asset. In our case, we're going to be doing perpetual inverse swaps. You don't have to go like too deep into these things, but it's basically just a thing that you can trade on OKX, which is inversely tied to the price of Bitcoin. And so when Bitcoin goes up, this thing goes down. When Bitcoin goes down, this thing goes up, and it does it in the same magnitude. And so it moves in the same way. Okay. So what do these derivatives allow you to do? They allow you to hedge risk. Specifically, what we're trying to do is hedge price risk. And so if you do business in Bitcoin, you're inherently long Bitcoin. Hedging with the derivative allows you to lock in the price of Bitcoin at a specific USD value. So let's go through this example, okay? And we're going to go through this whole example. Actually, let's switch over to the docs now because I spent the weekend going through and writing a bunch of documentation on this stuff and like helper stuff and all sorts of like the steps that you need to go through in order to implement this into your own projects, right? And so if you guys go to my GitHub, it's github.com/Kody Low/stablesats.docs. Then you can clone this down and you can run it yourself. I'll be walking through this and I'll also deploy this onto like a full domain name. I'll get that guys to you later so you don't have to run this yourself for it. But for right now, I'm just running it locally. Okay, so this is like my documentation that I worked through for this. So we're going to go through an Alice and Bob example of using synthetic USD on Bitcoin. Okay. And so we'll keep it here. And then we'll keep this one over here so that you guys can see sort of what we're talking about. Okay. Hopefully this is big enough for you guys to see. Get this over slightly. Okay. Cool. So Alice and Bob. Okay. So Alice holds 1 million Satoshis in her Bitcoin account, and she wants to move $120 to a synthetic USD account, right? So I've got 1 million Satoshis. So there's 100 million Satoshis in one Bitcoin. And I want to move $120 worth of that Bitcoin to something that's going to keep a stable USD price. Okay. So in this example, the price of Bitcoin at this time is $30,000. So she allocates 400,000 sats from her 1 million sats to the synthetic USD account. So you have to take the Bitcoin that you're going to use for the long part of this trade, and you have to segregate that out from the rest of your Bitcoin. So this is, I'm moving this into my US dollar account. So she's got 600,000 in her Bitcoin account and 400,000 sats in her USD account, which the current value of this is $120 based off of Bitcoin's price being 30,000. So when she does this, we're going to call this guy who monitors the USD account, the dealer. And so in cryptography, we call like the guy who's got like control over everything or whatever, the dealer, right? Is that the dealer, his name is Dave. He's going to, when he sees that move into the account, simultaneously open a short position on OKX. Okay. So right now, Alice has a Bitcoin account with 600,000 sats. She's moved 400,000 sats into a USD account, and that USD account, which is controlled by Dave, which is going to be the dealer, which is like the hedging strategy, stats thing. This is like the thing that's implementing the synthetic USD strategy, is going to use that 400,000 sats as margin for on one side for opening a short position on OKX. So now in the USD account, there's two assets. There's the 400,000 sats and there's the short position on OKX. Okay. So let's say 3 months go by and the price of Bitcoin falls by 50% to $15,000. So the amount that Alice had in her Bitcoin account is still 600,000 Satoshis, but the value of that is now $90 in US dollar terms. In the synthetic USD account, in the USD account that she moved over, which is the underlying Bitcoin that she had previously and the short, the net position between those is still $120. And the reason why is because the price of the Bitcoin went down, the price of the short went up. And so when she closes the short, the Bitcoin that she has remaining, along with that the Bitcoin that she made on that short, is going to be worth today $120. So the USD value stayed the same. This is very important. Okay. So let's say instead that the price surges of Bitcoin, instead of going down to 15,000, goes up to 30,000. So Alice's Bitcoin account still has 600,000 sats. They're now worth $360,000, originally 180. But her synthetic USD account, consisting of the net position between the Bitcoin she transferred to Dave and the value of the short position, maintains a value of 200,000 Satoshis or $120 because the value of the Bitcoin went up, the value of the short went down, and on net, they're worth $120 when you close the positions, ensuring a stable USD value through the hedging. Okay. So in this documentation, I also wrote this out in Rust, and it kind of walks you through here, right? And so when you go check out this documentation for this kind of just conceptually walks you through what I just talked through in code. Okay. So it's very important. So if anybody has any questions about that, like I can go over it, but it's very important that you understand the hedging mechanism involved over here. So I did some visualizations for this of basically how it works. So if the price of Bitcoin remains relatively stable, then it's very, very tightly linked. This is like basically the same thing as holding just normal Bitcoin, right? If the price of Bitcoin doesn't move very much. Now, let's say that the price of Bitcoin goes up by 1,000%, okay, over the course of like 30 days. This goes up by 1,000%. This is like the price of the Bitcoin spot position. The price of the value of the hedge that you've put on asymptotically approaches zero as the price of the Bitcoin position asymptotically approaches infinity. And the net always remains stable at that US dollar price that you originally locked the value in at. And the same thing for, this is like simulating if it goes down by 80%, right? And so then it goes through there. And then I've got, if you guys want, then you can run the Rust code over here, which I use to generate the plots. Okay. But this is a very important thing, right? Is that it's not like a synthetic USD is not like a token or something. Like if you're acting as a custodian, you can issue claims against synthetic USD if you wanted to. But the thing here is that you have something that goes up and something that goes down by the same amount. And so the net between those two positions remains constant. It remains the same US dollar price regardless of the way that the prices move going forward. Okay, cool. So then I'm filling out the rest of this as we're doing this. Like I kind of started on this documentation over the weekend. So over here, we've got futures contracts. And so this kind of defines all of the different types of contracts that you can use for this one and how the hedging strategy works. So that now I think let's go over to the specific implementation of this in Galileo. And we're going to spend a lot of time going through the code and talking through what are the specific parts that I have to pull out such that I can point this and run this synthetic USD strategy, hedging strategy against like an ETH node, an OKXchain, OKX wallet, whatever you wanted to. Because once you pull out the back end from Galileo, you can point this at anything that controls a crypto wallet. Okay, cool. So let's go over here. So let's go, if you guys want to find Galileo Money's implementation of this, it's you go to github.com/Galileo Money. And so on here, you can see all of their Bitcoin banking projects. All of these are open source. The specific one that we're interested in is StableSats RS. This is the Rust implementation of StableSats, right? So once you go here, then you're going to want to fork this repo and like clone it down and then start going through the code. We're going to go through a lot of it. I'm going to explain a lot of how this stuff works and the points at which you need to decouple it in order to run it against your own. Right now, they use this in production and they've been using it stably for about a year. And like they use this to manage USD balances for all of their Bitcoin, all of the people who use the Galileo as their Bitcoin bank within El Salvador. So they have a Bitcoin balance and a USD balance using the synthetic USD strategy. Okay. And they use OKX to do the perpetual inverse swaps. And you can, if you want to see the specific contracts that they use within the OKX client, it's got the specific ones you'll have to do. If you want to change this from Bitcoin to ETH or whatever else you want to change it to, then within the OKX client, you'll have to change the trading pairs. Okay. But let's kind of like jump through this code. So once you clone it down, it'll be in your, I like using VS Code. So then over here, here's the project. The way the project is built is using Docker, right? And so basically you need to install cargo for Rust. You need to install a couple dependencies for it. I've got walkthroughs for it. If you go over here to this one, architecture. Oh, sorry, I broke that. I'll come back to that. There we go. Yeah, so over here, this kind of goes over the current architecture. The way that the crates are organized is that it runs against OKX to do all the hedging. It uses OKX in order to get the prices. Galileo client over here is what connects it to Galileo Money's like backend for the Bitcoin wallet, right? So this is like one thing that you'll have to decouple. And so I'll go through the specifics of how to do that. Then you have the hedging and the ledger crates. These are the core hedging business logic, and it uses Postgres tables for the accounting. They actually use like company level, enterprise level, double entry bookkeeping accounting. And so you'll see as we go through this is that the bookkeeping for it is very, very, very particular. And like if you're an accountant, if you have any experience with accounting, it's unbelievable what they've done with this just in order to make this so that this could be like an enterprise level deployment so that like people everywhere and like company level could use like this for their treasuries. They could use it for anything, right? It does like all of the accounting, like according to double entry bookkeeping, which is really good. OKX client and OKX price crates. These communicate with OKX for placing trades and getting the pricing info. For the price server, it uses a Redis pub sub model for the pricing info from OKX. So basically he's continuously polling its OKX to get updated pricing info and then feeds those into the price server. And then this user trades crate over here. So this is the source of truth for the target USD liability. This is the hardest part to decouple from Galileo and what we're going to spend the most time on. Okay. So let me just kind of like go through my documentation here and sort of talk through when we're going to like conceptually the stuff that you're going to need to unplug in order to plug this into something else. So there's 2 points of coupling StableSats, hedging logic, and the Galileo backend, which we have to address. One is getting the target USD liability. And so in our Alice and Bob example that I had over here, it's getting this number, this USD account number. So it's how much is the USD value that I'm trying to create a hedge against, right? The other thing that he needs is a Bitcoin wallet, and he needs the Bitcoin wallet in order to move funds to and from OKX in order to place trades and withdraw margin when it gets too big and those sorts of things, right? Is that those are basically the two things that you have to unplug from Galloy and point at whatever you're getting into. And so this target USD liability could be as simple as just in a simple user's wallet, they say, I want this amount of my crypto in USD. For the Bitcoin wallet, you could unplug this and point this at any crypto wallet that has a pair against OKX's perpetual inverse future swaps. And so that's Litecoin, Bitcoin, ETH, OK, like basically whatever. We have like very deep order books, right? But so I'm being focused on the Bitcoin one because that's the current implementation. They only use Bitcoin. But once you unplug this, you could point this at whatever you want, okay? So currently, both these are deeply coupled to Galloy backend. The USD liability is more deeply coupled and tricky than the second. We'll have to remove both these couplings to plug stable sats into a different backend, okay? And so I just went over the current architecture. So you can run this locally. And when you run it locally, the way that they do it is built it with Docker. I don't like Docker. I like Nix. And so I wrote a Nix flake for this that does all of the dependency setup and all that sort of stuff for you. And so you've got a link over here for StableSats RS, like my fork of it, this branch, Nix flake StableSats. It's got a Nix flake and a just file. So it's kind of like easier for you to just run it yourself instead of having to use Docker and all that kind of stuff. So let's get into it, right? So the specifics of the two things that we have to decouple are the USD liability, because the way it currently gets it is it uses Galloy's own accounting system for its users for the Bitcoin balances and the USD balances. And then we have to connect it to a Bitcoin or a crypto wallet of some kind that's not connected to just Galloy's own Bitcoin nodes, okay? So let's go over here. So getting the USD target liability, right? So the way that this currently works, let me move this over again. Got a lot of screens. I need my APS code over here. So the way that this currently works is that in this user trades crate over here, where it says user trades in mod over here. So user trades is a table that StableSats is reading to and writing from, okay? So it uses Postgres tables for its double entry accounting. It's using SQLX. So you'll see these like SQLX queries. SQLX is like a Rust thing, command runner for SQL queries and stuff. And basically for all of the SQL queries and stuff that it does, it's using SQLX MQ, which is like a job queue from all of the different parts of the StableSats architecture. So that it can, if you wanted to, you could like deploy this across multiple machines and make sure that it's like not like doing redundant encodings and those kinds of things, redundant writes and those kinds of things, right? But so over here, StableSats gets the target USD liability from the Galloy backend by one of these job queues, right? For using SQLX MQ. There's a specific aggregate user in the Postgres table. So on their side, they use a specific user called dealer. And that dealer is the person who maintains the USD liabilities for all of their users, right? So this is an anti-pattern. When I talked to the CTO of Galloy, when he was walking through this, he was like, hey, you shouldn't do this yourself. But I actually think this makes a lot easier in order to point this against something else. And the reason why is because you basically just need to track the interactions that that one dealer has with the USD liabilities. Okay. So let's say like in our example that we went through with Alice, right? So when Alice did that transaction and Alice was like, hey, I want to lock in $120 worth of Bitcoin to the dealer, Alice does two transactions with the dealer at that point. The dealer receives Bitcoin from Alice and the dealer sends Synthetic USD to Alice. Basically what's happening here is that the dealer, the thing that you're going to have to get the USD liability against, has received some Bitcoin from Alice. And that's the Bitcoin that like dealers like that you're eventually going to use for doing the margin trading on OKX. And the dealer accounts for like, hey, this is how much the USD value of that Bitcoin was at the time that Alice sent it to me. This is what I owe her back at the end of this. Okay. The receiving Bitcoin is Alice locking in a USD price of some Bitcoin. The sending USD is crediting Alice with the equivalent US dollar of that locked Bitcoin at the time she locks it. So the logic here needs to correlate the receiving Bitcoin and sending USD to make sure they match up. And it has to identify what the price of Bitcoin was at the time Alice locked it up. right? And that's another thing I did over here on price oracles. I haven't added it yet, but I did like a whole thing on how to do price oracles if you wanted to get the prices from DeFi pools and those kinds of things. Okay. So where's the polling logic for this getting the USD target liability, right? It's in user trades job mod.rs. So in user trades, create, we go to job, and inside mod.rs over here, there's this specific function over here where it says poll Galoy transactions. Okay. So this job, this is what's registering it as a SQLX job, right? So it's saying, hey, do this every so often. And if you deployed this on multiple machines, it would make sure that the polling, if you're trying to poll like every 10 seconds or something, if you pulled this on multiple machines, the SQLX MQ would say, instead of, hey, every machine does it every 10 seconds. So you're actually doing it every 3 seconds if you have 3 machines. What this will do is it'll divide up the work across them and say, okay, you're doing it every 10 seconds at the increment, you're doing it every 10 seconds. And so you're actually doing it every 10 seconds across all 3 machines. Okay. So over here, right? So let's specifically look at this function. The important part is this thing, the Galoy execute. Where's that? Over here. Oh, I have it on this side. Okay. So poll Galoy transactions execute. So what this is doing is it's hitting against Galoy's backend, which is their backend accounting for the USD and the BTC balances of their users. That's what it's polling against. And it's looking for the specific dealer. And the dealer is, hey, when I receive Bitcoin and send synthetic USD liability to like the other users, that's what it's looking for. It's looking for like, what is the aggregate total position of all the USD liabilities for everybody on the back end over here, okay? So if you wanted to do this, you could have that dealer be like a custodial account, and then they have like sub accounts or whatever, or you could have that dealer be like just a single person who wants to use this USD hedging strategy, okay? But that's the thing that you have to change over here, right? It's in poll Galoy transactions execute. So over here, it's got 3 subsections to what's happening over here. So it's got import Galoy transactions. And what that's doing is it's basically using a cursor over that Postgres table where it's getting the data from. And it's saying, hey, based off of where I last looked, are there any new transactions? Is there anyone new who's trying, like any new synthetic USD liabilities that I just issued out? The imported table has a flag for whether the transaction has been matched. So once you pull those, then it pulls it into Galoy, it pulls it into StableSats, and then it writes it locally. When it writes it locally, it's writing it to this user trades table. So this matches the transactions and says, hey, have they been accounted for or not, right? So has the hedging mechanism that the StableSats is running accounted for this transaction, the way that this has changed the total USD liability? And that's done in the update user trades, right? So over here, if you look in execute, it imports the transactions, it updates the user trades table. And after it's updated that user trades table, it updates the ledger. And so the ledger is critically important. StableSats, this synthetic USD hedging technology, has its own internal double entry bookkeeping accounting ledger, right? And so there's not too many changes you actually have to make to this in order to get it to work, but it's very important that you understand what's going on here. So when it updates the ledger, it's got a flag for whether the transaction has been accounted for in the system. Before you call this the new transactions haven't been accounted for, and the counting in the user trades table is what needs to hand it off to hedging. So if we go over here and look in update ledger, this is kind of the last point that we need to get to before we can kind of like decouple this. So if I go to update ledger, yeah. So if we go over here to update ledger, right? So we see over here. So this is like the, oh, we don't have to do this part. No. So that's the revert part. This is the part that is important. Okay. So if we go over here, we find unaccounted trades. Okay. So this is the point where the ledger is looking against the user trades table and saying, hey, are there any new trades that you got from the back end that by dealer that I haven't accounted for yet? If there is an unaccounted trade, if the net position is to increase the USD liability, Then it runs ledger user buys USD. So this is increasing the US dollar liability of the dealer. Else, it would be user sells USD. And so this is someone on the other side is decreasing their USD exposure. So they're unlocking Bitcoin from the synthetic USD contract mechanism. And so we need to decrease the hedging. Okay. So everything that I just went through up to this point, this is the thing that you have to pull out and point at a different USD target liability, like a target amount of what percentage of your Bitcoin or your crypto or whatever it is that you're using for the asset for this side, what percentage of that, or like what is the total amount of that you want to have a locked in USD price. Everything that I covered over here of like getting the data from the Postgres table, writing it to the user trades table, that's the stuff that you have to pull out and point at something else to get the USD liability. Okay. Once you get to that point, all of the hedging logic is triggered by these ledger updates. And so it's not every single time that there's an entry, it's going to like change the position. What it's going to do is it's going to trigger and say, hey, do I have to update the position? Because if it's just like a small amount up or in either direction, then it doesn't matter. Like the perpetual inverse futures contracts, those are operating like units of $100. And so if it's just like $5, $6 either way or whatever, then it won't update it. But if there's a big move, then it will update it, right? So all of the hedging logic beyond here is like already modular, like separated out or whatever. Like you don't have to touch any of that, okay? You just have to update to here to get the target USD liability. So if you put the target USD liability into this format such that the ledger can understand it when it puts it in, then all the hedging logic will work. It will connect to OKX. It will do all of that for you, okay? Cool. So this is like the USD liability side of things, okay? All right. So yeah, we go over here. I think that was all I had for here. Yes, for updating the ledger, it does that. So how do we decouple this user trades module? I think I went over this stuff. Yeah, so basically, if you wanted to like start this as a project, clone this down. So fork the project down, clone it. Sorry, fork the project down, make a new module. In that module, start with this update ledger function. And then backfill in, like use the Rust compiler to help you as you're doing this. It'll be very helpful for like making sure all the types match and all those kinds of stuff, right? Backfill in all of the requirements that you need to do of writing to the user trades table, having this read from the user trades table such that it can input it into the ledger. And then all of the hedging logic is already implemented. Okay. But so this one could be, you get the USD asset liability from like, like a stability pool, like a liquidity pool. You could get it from like, hey, I want to implement this with the OKX wallet and have like a synthetic USD value that I can like peg into and out of from like the crypto side of things, like all that sort of stuff. You can do all sorts of crazy stuff with this. But if you want to, you need to get the USD target liability of like, this is the amount that StableSats needs to be hedging for. And that's the way to start it, is like start from this update ledger and then backfill it in. Okay. Making sure it works. If you have any questions, feel free to add in the chat. Okay, so that's like the one half of like the USD half. Now we can talk about like the Bitcoin and crypto half, okay, of that. StableSats needs to be able to control a hot wallet that it can move, like it can deposit and remove from like margin positions from the exchange in order to do this hedging, okay? And so this is going to be like a lot more simple. This is not as complicated for this one. So if we go over here, and I made this other one for how the ledger works, right? We don't have to go over all this, right? But I made this other section on how the ledger works and kind of walking through like the templating system for it. And so if you wanted to point this as something else that's like not BTC, if you wanted to point at ETH, which like also has like good liquidity so that you can do this trading against, whatever, like this is the way that you would update the ledger entries in order to account for, and instead of it being Bitcoin, it being ETH. Okay. And this is the OKX engine that they run. They haven't updated the naming. It's OKX, not OKEX now. They haven't updated that yet. But for this like OKX engine is what feeds the ledger in. And then it's what's making the decision of like, hey, has the USD target liability increased or decreased such that I need to adjust the hedging positions on OKX. Okay. So let's go to the next part. using a different Bitcoin wallet. Okay, so decoupling the Bitcoin wallet. So again, like this part is going to be significantly less work, right? And so if you wanted to, like as part of the hackathon, like just decoupling this would be like worthwhile, right? Like decoupling the USD liability would be like huge, and being able to point that at something else, like that's like a huge lift right there. And being able to do that is incredibly impressive and going to be like incredible service to like basically like humanity of being able to create synthetic USD for like anything else that you want to, right? But like, and that would be like an awesome project. This is like much easier to do. Okay, so let's start going over this. So you basically just need to hook in the spend and receives for a standard Bitcoin wallet or crypto wallet instead of Galloway client's Bitcoin wallet at the places where the hedging module moves funds in and out of the OKX for the margin requirements. Okay, so when you want to put one of these short positions on, you have to put up some Bitcoin as in order to open the position. And when you close the position, you withdraw the Bitcoin, right? So that's what the hedging logic does. Right now, it's coupled to Galloway client's specific Bitcoin backend, but you don't have to do that. So let's look at the adjust funding job. So the adjust funding job is it's one of these SQLX jobs that's running continuously. And it's like, hey, do I need to adjust funding based off of the ledger entries, right? Like the trigger for these adjust funding jobs is that it sees that the ledger entry has been adjusted. Okay. So over here, let's go to hedging source OKX job. Close this. Hedging source OKX job. Adjust funding. Okay. So this is the other point that you're going to have to decouple and point at like something else. Like you can point this at the OKX wallet. You can point this at whatever. It just needs something that it can like move money to and from OKX for, right? And they should match the Bitcoin that's been allocated based off of the target USD liability, right? Okay, so if we go over here, look at this function. So this execute over here, right? If we go down, go look at this match. So these actions, right, are basically it's matching like, hey, this event happened, and this event happened. And so which action am I supposed to be doing here? If the funding adjustment is do nothing from the ledger, then it just does nothing, right? Because the ledger said from the ledger crate, after like the USD liability changed slightly, say it only changed by like $5 or whatever, that's not worth like the $100 of, that's not like $100 move in either direction in order to do this hedging, right? So it just says do nothing. If the action is increase the amount on the exchange and open a larger short position, or if it's decrease the amount on exchange and close the existing short positions and withdraw those, right? That's where it gets interesting. So over here, there's two of these in an enum, two of these enum options, okay? OKX funding adjustment on-chain deposit and OKX funding adjustment on-chain withdraw. So I've got these in the notes over here, and I've kind of like gotten rid of the parts that like aren't really important right now. The important parts are in the on-chain deposit, it gets a funding deposit address from OKX. And so it's like hitting against the OKX API and saying, hey, where do I deposit my funds to? It does some logic over here. And then over here, at this line, it says Galloway.send on-chain payment. Okay. So this is the point that you would need to pull out the Galloway client and put in your own wallet client, right? So the wallet client could be anything. It could be an OKX wallet. It could be a Bitcoin wallet. It could be a Bitcoin node. It could be a Lightning node. It could be an ETH node. It could be like OKXchain node, whatever you want to be. Like this, you can do like just need something that can deposit and withdraw Bitcoin on this line. Okay. And in the code, that's right here. It's line 154 in adjustfunding.rs. Okay. The other one is the on-chain withdraw. And for the other on-chain withdraw, instead of getting the address to deposit it to from OKX, it gets the on-chain address from the Bitcoin wallet. So it's saying, hey, I'm withdrawing. I need to get an on-chain address from the Bitcoin wallet, put that in and say, hey, withdraw to this address. Okay. So that is this line of code. those are the two lines of code that you need to change in order to point this at a different source of funds for the Bitcoin wallet to move it in and out. Or if you'd have to do some more changes for like ETH or like anything else that you have a trading pair with, right? But those are the two lines that you have to do. And so if you were going to do that, the way that I recommend, and this is the idea that the CTO of Galloway has for it, is that you make a wallet client trait for the on-chain deposits and withdrawals. And so for those of you who want to program Rust, traits are incredibly useful for this one, exactly this sort of thing, right? So to create a more generic wallet client, you can define a wallet client trait that can be implemented by any Bitcoin or crypto wallet. So in this example, we're going to create a trait with the two required methods, on-chain address and send on-chain payment. Then you can update the execute function in this adjust funding.rs over here at those 2 points that I showed you in order to implement that trait. Sorry, to use that trait instead of the Galloway client. So first you create the wallet client trait, which is going to look something like this. And then you update the execute function to use this trait in those two places instead of the Galloway client. And so the code would look something like this. This was my first pass at trying to do this myself. Okay. So here, instead of taking it from the Galloway client specifically, this takes it from any wallet that implements the wallet client trait. And the two things that wallet needs to be able to do is to provide an on-chain address and to send an on-chain payment. And any wallet that does those two things that you can hook into a Rust implementation, you can use with StableSats. Okay. That's like critically important of like how awesome this is, of that you can basically point this at anything. Okay. So here we go. So that was my first pass of trying to do it. So you can like copy that code if you want. Okay. Cool. I think that covers that part. Okay. So as we go over here, I'd really appreciate any questions if I went too fast on like how the synthetic hedging, USD hedging works and those sorts of things, just because I know that can be complicated, but kind of the summary position of this, right, is that it kind of looks conceptually something like this. So if I scroll back, yeah, there we go. It kind of looks something like this. Okay. So whoever the Bitcoin balance is, or whoever the crypto balance is or whatever, right? The rails in and out at every point are still crypto. But any wallet that can maintain a crypto balance can use this synthetic hedging strategy to lock in a US dollar price for some of the crypto balance that it's holding. And so the process for that would be, let's say I receive a payment from Defu. I receive that payment, and the moment that it hits my wallet, let's say that I don't want to deal with like the price volatility of Bitcoin at all. I just take the entire amount that he sent me and I use this strategy for it. And so I put off to the side in like this, think about it like the dealer that we kind of went over of the Bitcoin that I received, and simultaneously open a corresponding hedge on OKX. And now at the point that I want to pay somebody and withdraw from that USD account, I close those positions and send out Bitcoin. And the amount that I send out in Bitcoin is going to be the same amount in USD as the amount that as the USD amount when I first received the payment. So the entire time that I was holding Bitcoin, or the entire time that I was holding ETH, or that I was holding anything, my price exposure was to US dollars, not to the underlying crypto. Okay. And so what's cool about this is we don't touch the banks at all. We don't need the banks at all. All you need is a place to trade this. And so right now, the implementation currently just uses OKX. But one of the critiques that I've heard from people, even within the company, is that that's a centralization risk, of that you don't want to just rely on a single centralized exchange. So if you want to see an example of how you could use this against multiple implementations, there's currently PRs open for exchange allocation and adding different price sources and different exchanges and allocating across all of them. And so this would be a like, while OKX is like the best place for you to do this in order for you to do this hedging strategy and that sort of thing. If you think that it's a risk, and if you want to like implement this on DeFi, and if you want to implement this of getting the price orders from like a DeFi contract or doing the trade using like a liquidity pool, those sorts of things using DeFi, these would be the things to look at, where this is how you would implement getting a different price source, how you would implement using multiple exchanges, not just OKX, but also like a DeFi pool on OKXchain or like a DeFi pool on some sort of EVM system, right? And then also, how do you implement the allocation logic of that you use that you go across to multiple exchanges and multiple sources of liquidity? Okay, so those would be the ones to look at. Okay, so kind of like last sort of stuff before we wrap up for this is I go to, where's my presentation? Okay. Okay, yeah. So this is me on Twitter, right? Like, I would love to help you guys with this. It's like, I think this is critically important for Bitcoin and crypto, like right now, of that this is a way to do US dollar denominated assets without touching banks anywhere up or down the stack. So I would love to help with this. I've done a lot of work on this stuff so far, and like all I want is to like make this a reality and to see every user of crypto, of OKX, of everyone doing this all the time in order to manage their USD so they never have to touch banks, right? So I'm at Kody Low on Twitter. Please feel free to reach out to me, and like I will try to help you out with this as much as I can. I'm going to be on site on Friday and on Sunday. I'm not going to be there Saturday, but I'll try to be there Saturday night. But like my DMs are always open on Twitter. Okay. So specific hackathon ideas, right? So let's go over here. Oh, sorry. Yeah, just kind of move this around. Sorry. Okay, cool. So specific stuff, and we've got some prizes that you could like win if you like do this sort of stuff, right? So using this StableSats RS repo, pull out the Galloy backend and point it at just a standard Bitcoin node, the OKX wallet, or some other backend for the asset hedging and or the USD liability, right? Like I kind of walked through all the steps of that you'd have to do for this. I'll continue working on this documentation and I'll put it onto a static site so that you guys can hit it instead of having to clone the repo down, right? So re-implement this is that currently this is written in Rust, and like, well, like personally, I love Rust, right? In order to make this cross-compatible with a bunch of different applications, kind of get the widest developer adoption for this, like try to rewrite this in Golang, right? Like this is the way that this was written was for like enterprise scale applications with like double entry bookkeeping, accounting, all this kind of stuff. Try to re-implement this like core logic in Golang, and like maybe you do a smaller deployment, something that can just like manage for a single user and that sort of thing, right? Once you do that, it'll be super easy to integrate it into Geth, OKXchain, Ethereum applications, like Bitcoin. Like within Bitcoin, you can do like, you know, a Lightning extension onto LND. You can use BTCD for the backend, whatever it is, right? Like all sorts of stuff. If you like try to re-implement this in Golang. If you want to do this related to like a DeFi topic, that's the stuff that you're interested in, right? Like writing the core logic, hedging logic out in an EVM-compatible smart contract and deploying it to an EVM-compatible chain, like OKXchain. Or if you wanted to, there's now you can now do EVM rollups onto multiple different chains. So you can do an EVM sovereign rollup onto Bitcoin using something called Rollkit, and like you could do the same thing on OKXchain either. But like implementing this core hedging logic as like a smart contract that automatically executes instead of you having to run this on a server. Okay, like all of those would be really unbelievably awesome hackathon ideas, and like a couple other ones, right? Of like getting the price quotes from multiple sources and allocating across different liquidity pools, right? So like DeFi pools, multiple exchanges, balancing across different exchanges, all those kinds of things. All of those, just using synthetic dollars in those ways, would be unbelievably cool hackathon ideas and like totally manageable for you to do with like a good team of guys. Like if you want to work on the Rust stuff, like I'm more than happy to help you out on that stuff. But like this is going to be super, super, super huge for crypto and Bitcoin. Okay, so yeah, so that's my presentation. So if there's any questions, like I'm happy to take those. I've got like 15 minutes for questions if there are any, right? But otherwise, like I'm at Kody Low on Twitter, and I am more than happy to help you guys out with this stuff. So.
Okay, thank you, Kody, very much for your time. And I learned a lot from this presentation too, and I will definitely follow you on Twitter. So especially the last part, I would say the hackathon ideas, I really love them. And for all the teams out there, if you use the Kody's ideas and win some prizes, finally make sure you split with Kody, okay?
No. If you do, I will donate this to further development of this idea and like further like paying for a developer to continue working on this. Like this changes everything, right? Like crypto without the banks. Like we're finally decoupling from them, right?
That's the spirit. Okay, so we are now open for questions. If you have any questions, feel free to type them in the chat box and the Q&A box. And for those who are watching this video recording after this meeting, just FYI that this hackathon will be an on-site hackathon in Santa Clara, California. And if you are joining us from other states or other countries, feel free to go to our hackathon Discord and find OKX Discord channel. OKX Hackathon channel, and under it you will see a grouping. So try to go there and introduce yourself and find some local teammates from Santa Clara, and then you can team up and good to go. Okay, do we have any questions? Let me see. I didn't see anything yet. Cool. So I think we should be okay to wrap it up. And if you have any other questions, feel free to drop them in our Discord channel. Just simply go to OKX Hackathon and find tech support over there. And Kody will be on site Friday and Sunday. He will also, together with other OKX experts, answer any questions you have. Okay, cool. Yeah, I think that's pretty much it. Thank you everyone for joining us. And this is OKX Hackathon Workshop number 3. We have 2 more coming out. One is tomorrow, the other one is Thursday, all at 6 p.m. PDT. Feel free to join us at that time. Okay, cool. Okay, thank you everyone. Thank you, Kody.
Yeah, thank you. This is awesome.
Yeah, we will see you next time. Bye-bye, guys.